if you haven't got the majority there, I would suggest you spend some more time remembering them. Okay, you need to know these off by heart, okay? I've shown you how to derive them if you want to rely on that. Okay, otherwise... Obviously the table needs to be in the right spot, but everything else, the 5 identities do not necessarily need to be in order. However, the order I have done them is a process, okay? I didn't just randomly do one and then move on to another. I actually went through and it worked because of the process. Alright.
The one in the corner is not sexy.
Cozy.
The one in the cozy is sexy, yes.
Okay, so summary of what some of the stuff that was covered last week. Okay, sign of 30, Josh. Sign 45, Bo. Mina, cos of 45. Kyle, tan of 30.
1 over root 3.
Good. Robin, cos of 60.
1 over, root 3 over 2.
Cos of 60.
1 over 10. 1 over 2.
Michaela, tan of 60.
Root 3.
Good. Josh, tan of 1. Sorry, tan of 45.
Sorry for the answers, though.
Right. And Kyle, cos of 30.
Root 3 over 2.
Good. Okay, remember your pattern. Sorry. And sign of 60, Robin.
Root 3 over 2.
Okay, remember your patterns in that table. Okay, go back to your complementary angles work. So these two are the same because cos of 30 is the same as sin of 60. Right, these two are also the same. Sin of 30 is the same as cos of 60. Remember your complementary angles work. And these two are the same. Okay, sin of 45 is exactly the same as cos of 45. Right. Also with your tan, they increase in magnitude. So root 3 is the number which is bigger than 1. So 1 over a number bigger than 1 is going to get you a number overall smaller than 1. Right, 1 and then root 3, which is also a number is bigger than 1. So that will be bigger than that value. So they actually increase as you go along the table. That's another way to remember it. Alright, Josh, one of the 5 identities.
1 plus tan theta equals sec theta.
Tan squared theta is sec squared theta. Amanda?
1 plus cos squared theta equals cosec theta. Squared theta.
Go sec. Okay, the one with the tan is sexy, one in the cot is cozy. Alright, Robin, another one?
Tan equals sin theta over cos theta.
The tan theta is sine theta over cos theta. Kyle, another one?
No, I don't know anymore. I can't remember them all. Robin does. Robin has 8 of them.
Michaela?
No. Yeah, cot theta equals cos theta over sin theta.
Good.
I don't remember the last one.
And that's,
And Robin, the last one.
cos squared theta plus sin squared theta equals 1.
So sine squared theta plus cos squared theta is 1. Okay? Right, so you need to know those. Alright, so I would suggest you have them written down somewhere where you're looking at fairly often. Okay, and be able to spit those values out. Alright? So, the reason why they're in a set order, so I've done this in a set order, so number 1, number 2, number 3, doesn't really matter the last 2, number 4, number 5. Okay, so if you remember tan theta, which is sine over cos, alright, cot is the inverse of tan, the reciprocal of tan, so all you have to do is flip the sine and cos over the other way. Okay, now using your formula for the equation of the circle, this is what we're learning in more detail next topic. Okay, sine squared plus cos squared of the same angle is equal to 1. Right? If you don't remember 1 plus tan squared is sec squared, and if you don't remember 1 plus cot squared is cosec squared, okay, if you don't actually remember those, okay, and also I've given you a couple of tips to remember them, what you need to do is go back to equation 3 and divide everything by sine squared or everything by cos squared, and you'll get equations 4 and 5 respectively. Okay? So if you don't remember, you need to be able to derive them. Okay? So this is probably the first major component of new work for you guys. Okay? So you need to remember those. Alright? There's no formula sheet, there's no assistance on your exams, anything like that. Okay? You are required to know them off by heart. Any questions on those? Who feels like they know these very well?
Nope.
Who feel like they don't know them at all? Good. So partly everyone? Partway learning? Okay, so we're splitting this out at the start of each lesson. So we're getting very good at them. Alright? So remember also for that table, I have done a lesson on deriving. Okay, so actually working out using your right angled isosceles triangle, which means there's two 45 degrees of side lengths 1, 1 on the equal side, and also equilateral triangle, which has been cut in half, and each of the sides of the equilateral triangle is 2 units long, so you have an angle of 60, 30, okay, use Pythagoras, etc., and then you'll be able to derive all of these if you cannot remember the table off by heart. Okay? But for your time's sake, I suggest you be able to regurgitate all this information here. Okay? Any questions? Right, so last lesson we looked at these 5 identities. Okay, and we started to do some proofs. So what I'll do is I'll do that first proof again. So on page 50, today is the 26th of the 5th, and we're up to example E. Okay, so you're asked to prove. Alright, so we had E, which was tan of the angle capital A times sine of the angle at capital A plus cos of the angle at capital A. We need to show that it's equal to sec of the angle at capital A. Got a couple of UH students outside in another class doing tests and probably heard of all these tan sexy comments and all that, and they'll be very curious, I'm sure. Right, so when we go through a proof, okay, when we go through a proof, alright, what you are required to do is show the expression on one side, bad Robin, what we're required to do on one side of the equation sign, of the equal sign, sorry, you need to be able to set that or the expression on one side to get it to equal the expression on the other side. Okay? Yep, and I'm going through it again.
Okay.
Because people were a bit lost yesterday, so I thought fresh start, we'll start with all of them again. Right, so what you need to do is use your 5 identities. Okay? To be able to manipulate one side of the expression of the equal sign to get it to equal the other side. Now, the side you pick, okay, would usually be the side that has the more information in it. Okay, so I can do more with this side because there's more bits and pieces there. Alright, all I can do on the right hand side is just write 1 over cos of theta. Alright, which doesn't help me to be able to show this. Alright, so pick the side that seems like you'll be able to do more with, and then state the left hand side or the right hand side. Okay, so we are focused on this expression here, and we're going to get it to equal eventually at the end sec of the angle capital A. So we have tan. So the first thing we can write for tan is sine capital A over cos capital A. Please don't write little a's. Right, the formula is given to you in capital A, so rewrite it in capital A. And then you still have the sine of the angle capital A, and the rest of the expression plus cos of capital A. Okay, so sine of capital A times sine of capital A is sine squared of capital A. Alright, so just tidying up that expression there. Whenever you have a fraction, okay, particularly when you don't have the same denominator, alright, the first thing you would do is put them over the same denominator. Okay, so this has a denominator 1 if there's no denominator by default. Alright, so therefore the lowest common denominator is going to be cos of capital A. So if I introduce the cos of capital A on the bottom of this fraction from 1, okay, so I'll need to actually multiply 1 by cos of A, and I'll also need to do the same to the top. So cos of capital A times cos of capital A. Okay, so in other words, if I cancel this cos on the bottom with 1 on the top, I'm left with just the cos of A, which is what I've had on the previous line. So, equals sine squared of capital A, cos A times cos A, which will be cos squared of capital A. And when they are over the same denominator, we can add the numerators, or subtract the numerators if there was a minus sign, and the denominator stays the same. Okay? And then using identity number 3, okay, so sine squared plus cos squared is 1. So it'll be 1 over cos of capital A, and then going back to your reciprocal ratios, okay. So 1 over cos, we need to pick the cosec, sec or cot that has C as the third letter, which is sec of capital A. Okay, and now we're equal to what we got on the right hand side. So equals RHS. Okay, so this is what you need to do when you set out a proof. Okay, you start with one side, show that equals the other side. If you can't show that equals the other side, you stop and then you start at the other side and show it is equal to one of your expressions from the left hand side. Okay, but it won't always need to be the case. Should be able to, in most cases, be able to get it similar in terms of getting the exact expression on the other side of the equal sign. Alright. Any questions on that one? Right. Sine theta plus cos theta all squared plus sine theta take away cos theta all squared, and show that's equal to 2. Okay, so again I'm going to pick the side that I'll be able to do more with. Okay, so not a lot I can do with 2. Alright, so I'm going to pick the left hand side. Alright, now identity number 3. Sine squared plus cos squared is 1.
Yes.
Not sine plus cos is equal to 1. So you cannot put 1 square and then you have this, which is also a minus sign, which is different anyway. Okay, so it is sine squared plus cos squared is equal to 1. So what can I do? Expand it. Alright, so we've got sine squared theta, so this squared, plus 2 times the product of the two terms in the brackets. So multiply the two terms together and double it. So you have 2 sine theta cos theta. And now extension student, 2 sine theta cos theta will be something you'll be looking at in extension 1.
It looks so much fun.
Plus cos, oh, we're only merely on tip of the iceberg in terms when it comes to trig.
Cool. Thanks, Josh.
Okay. Alright, plus, now expand the second one, so sine squared theta, take away 2 sine theta cos theta, and then the last term is always positive. Okay, so this is going back to chapter 2 and chapter 3. So we algebraically expanded it, and then chapter 3 was involving equation where we have to set it equal. Okay, so if I look at my expression, let's have a look. I've got 2 sine theta cos theta. Take away 2 sine theta cos theta. Okay, so they'll disappear. And I now have sine squared plus cos squared. I also have a second sine squared plus cos squared. No, they don't. The 2 in the middle cancel out, yes? Alright, so I have 2 lots of sine squared theta plus cos squared theta. Okay, or you can simply write 1 plus 1, that's fine. Okay, which is equal to 2 lots of 1, which is 2. Okay, and then at the very end, which equals the right hand side. Right, 1 over sec of x, take away tan of x, take away on the denominator sec of x plus tan of x over 1, so 1 over that, which equals 2 tan of x. Okay, so you're required to prove. So the first thing you need to do is identify the side that you'll be able to do more with. Okay, more often than not it will be the left hand side. Okay, because that should be your hint. Start on the left and you show on the right. Okay, so left hand side. What would I do first? Hint, hint, there's 2 fractions involved. Right. So the common denominator will be that times that. Okay, and if that's the case, we go through the process of cross multiplying for the numerator. Now, you have a minus sign in the middle, and you have more than one term when you multiply. So what you need to do is have that section in a bracket. Or when you expand, you are changing the sign in the middle. Okay? Alright, let's look at the numerator first. Give people a chance to catch up.
It's cold, isn't it? You don't feel it.
But your brain should be nice and warm now.
You got me, huh?
Alright, let's look at the top. So we have sec of x plus tan of x. Right, remember the identities are squared, not sec and tan. Right, they are sec squared, tan squared, cosec squared, cot squared. Right, everything's squared. So you can't use those identities and take the square away. Does not work. Alright, so we have sec of x, take away sec of x. Alright, so that means those 2 terms will cancel because you're taking away the same thing from from itself. Then you have a positive tan x, take away a negative tan x. Alright, so the 2 minus sign will become a plus sign when you expand. So we're going to have on top 2 lots of tan of x. Alright, so we're just about there. However, we've got to fix up the bottom. So we have the difference of 2 squares there. Alright, remember the process, if you have the same variable on both sides, the only difference is the sign in the middle. Okay, it would be the first term squared, take away the second term squared. Okay, so a minus b, a plus b. Alright, back to your mathematics. So sec of x is a, tan of x is b, and the only difference is the sign. When we expand, a squared take away b squared. Alright, so this becomes sec squared of x take away tan squared of x. Okay, so I wouldn't finish that proof just stopping there before I've done anything with the bottom. You need to justify it's 1. Okay, so identity number 4 was 1 in the one with the tan is sexy. Okay, so I need sec squared take away tan squared. So if I move this on the other side, so take away tan squared of theta for the formula, I'm left with 1 on the left hand side. So equals 2 tan of x over 1. Okay, and at this point you can then say which equals RHS. Okay. But because it's a proof, you need to show everything. So you need to show at least this expansion and that it results to 1. Okay, if you do not show that, right, you for this particular style question, you may not get your full marks. Okay, so a proof requires a complete set out of your reasoning. Right, any questions on that example? It's GH. Right, 1 minus tan squared of capital B over 1 plus tan squared of capital B, which equals cos squared of capital B, take away sine squared of capital B. Alright, this one's probably a bit iffy in terms of which side you would start with, because you could probably do something to both of them. Because you have tan squares on the left hand side, you also have cos squared and sine squared on the right hand side. Okay, so if you started somewhere and continued and used your identities, you would probably get to both sides in about the same amount of working. Okay, but if you're unsure, always start on the left hand side. Okay, if you're really not sure and it's not obvious that you would start on the right hand side and make things a bit easier for you, start on the left hand side. Alright, so what is the identity involving tan squared and 1? Yep, so 1 plus tan squared theta is sec squared theta. Alright, so notice the sign in the middle. Okay, so I've got 1 plus tan squared, which is sec squared. So I've got 1 take away tan squared of beta over sec squared of beta. And basically I need to now show that is equal to cos squared of beta take away sine squared of beta. Or b. I don't know what it is. Okay? B, beta. I don't know. Have I used beta in mathematics? Or is it just extension? Yeah, so.
Well, it's originally were all from the extension.
I forgot the properties for it too.
Hey?
I forgot the properties for that. And I wrote them down like every day.
Yeah.
Alpha, beta, alpha plus beta,
Uh-huh.
gamma equals.
Go on. Alright, so what I need to show is cos squared beta take away sine squared beta. Okay, in order to achieve that, I'm looking at my question. Now I have a sec squared beta, which is the reciprocal of cos squared. Okay, so I have a sec squared, which is the reciprocal of a cos squared. So what I'm going to do is split it up like the following. Okay, because I'm noting I have two terms here with a minus sign in there. Okay, so if I can show both sides, it gives me cos or sine or vice versa. Alright, I'll be done. Does everyone understand what I just did there? It came from basically because we've got this denominator of one term and the numerator consists of two terms.
You've just
I've
broken it up.
split it up, yeah. Gone backwards if I were going to simplify that. Okay. Alright, what is 1 over sec squared of beta?
Ah, cos.
Cos squared. Okay. Now, so again, we have sec squared of beta, which is cos squared of beta. And what can I write down for tan squared of beta?
Sine.
Well, I'm looking at getting a sine squared beta.
It's the
So what would I
first
write?
identity. You've got to rearrange the first identity.
Or write down the first identity, yes. Sine squared beta over cos. Okay, so that first identity was tan theta, which is sine theta over cos theta, which also means if I squared everything, that will also be a true result. Okay? However, I can't take the square root of the third, fourth and fifth identity and it still works. Okay? Right, so if I do that, the cos squared cancels on top and bottom. Okay, and I get what I get on the other side of the equal sign.
Where did the sec squared go?
I've written that as the cos squared beta on top. Just like I've done here.
Oh, okay.
Yep. So tan squared beta, which is that, and sec squared beta, which is that. Okay? You could do it the other way around if you needed to. Right. Question. Do you want some time to work on that, or can I move on to the sign, or? Everyone has seen a sine rule before, haven't you? In non-right angle triangle? You don't know?
We're halfway there. Done. Halfway with you.
Mhm.
Except that the second half is always the hardest to work.
Well, there's 15 minutes to go, so would people be prompted to do some work, or would you... I'll do some theory.
Are there any more examples on this?
Not this particular section, though. Okay, up to and including exercise 6.9, please. Now, lucky for you, very lucky for you, I think. If have I told you I'll be having the last 2 weeks off this term? I'm having the last 2 weeks off. Okay, having a bit of leave. Taking my entitled father of new baby leave, 2 weeks. So that'll be the last 2 weeks of the term and the Friday before as well. Okay. I don't know who will be taking you, but you'll be continuing on your course.
We had cool teachers last time.
Yeah, but they didn't know.
Yeah.
They didn't know.
We had no clue what they were doing.
Well, I know for a fact the teacher that is replacing me has done mathematics in her HSC. But whether she can do,
Is it the chick we had last time?
hey,
Yeah,
Mrs. Singh,
Mrs. Singh.
yeah,
Oh.
with the short blonde hair.
Yes.
Oh, that one.
Yep,
Yes.
younger one. Yep,
Yeah.
she'll be taking my classes for those 2
The
weeks.
24-year-old? She's really pretty.
24-year-old.
Yeah.
24-year-old.
Yeah.
Yeah, we
She's
need
younger
to
than
help.
me.
What about
Well, I
extension?
asked. I was
Will
like, how old
will
are you?
extension continue or just stop?
Oh, can we do
Either Mr. Smith or Mr. Harper will be taking your extension lessons. Okay.
Man.
Wait, should we get through
Oh, yeah,
this
Mrs.
before
Smith
you
is
leave?
Hey,
Will we get through
we're going to finish Trig, but when you get up to functions and graphs, which will pretty much be you guys having some form of technology in front of you and going on to GeoGebra and checking your answers as you graph them
Can
while...
we have Mr. Smith for extension because he's knows.
Say it again, sorry.
Can we have Mr. Smith for extension because of the he said he's really good with the permutations and all that.
But I'm going to be finished that section and you'll be doing extension Trig.
Oh.
Mr. Harper.
Yeah, go half is good.
I don't know. We'll have to
That's me, actually.
have to see the availability of those people.
Fresh.
Okay, so that will mean that I will not get a chance to check your books until next term.
Woo!
Yeah.
I'm not
By the
happy.
looks
This
of
is
it.
the first time I've done everything. Every single question we needed to do. I didn't even mark it.
I apologise.
I'll procrastinate more.
Now, I did have the intention to mark your work and check what you're doing and mark all your assignments, but there's just a million other things that just got on top of this. Okay, so I do apologise for people who are diligently getting their work done.
Don't stress. Don't stress. I understand.
However,
Like,
okay, those people who have not completed geometry work, okay, you have a lot of work you need to do. Okay, as well as everything in Trig. Now that we are picking up on new stuff, okay, you're learning new stuff.
I hate going out of
I'm gonna cram it all in just
my
to
hate going out of my
Now, I may still have a chance to check your both your extension in mathematics before I leave. I may still get a chance. Okay, so I still suggest you are having them ready to hand in.
I like what we're doing in extension right
But the Trig won't be due till next term anyway, because I'll be gone by then.
now. You're bad.
So Amanda and Michaela,
What?
Robin was yawning and I had a bit of paper in my hand, so I threw it in his mouth.
It's like the one time
Right,
we threw
let's
that
get some work
soup
done.
really cool.
That was beautiful.